Let's start with lecture 11, which is about input-output systems or I/O systems. Here you have the written instructions for the main book of the course and the extra facultative reading as always. And this is the agenda for today. We are going to start, of course, with the introduction. At this point in the course, we know that the main job of your computer is basically to process stuff, crunch data, and perform input-output. And this usually depends on what the user is doing on requests from the user. We have the hardware and we have the operating system that is there to help managing and controlling input-output operations and also coordinate the devices that we have for input-output. So what we will do in this lecture is discuss and explore a bit the structure of the part of the operating system that is about input-output. We will see why there are, as always, trade-offs and complexities also when it comes to that part of the operating system, and discuss a bit performance. We will see why choices we have or choices we make at the operating system level and at the hardware level have an impact on performance. It's not really something new because now if you understand how virtual memory works, for example, you know that it is fast also because we have interrupts. That is one of the many examples between cooperation between the operating system and the hardware that I keep mentioning since the beginning of the course. So the first or the main challenge from the perspective of input-output is to control in a good way all the devices that you are connected to the architecture. So to your computer, for example. So why is it challenging? Well, you have completely different types of devices. Some of them are defined to give only input or only output. Some of them are bidirectional, so you can either write or read from them. And when the devices fail, the consequences of a possible failure can go from almost unnoticeable to disaster, okay? Some of them require control in real time because it works only if you operate on them within strict deadlines. Others are not really, for others, deadlines are not really that important. So if the computer is late reading a key or pressing your keyboard by a couple of milliseconds, you don't even notice. If the operating system that controls the flaps of a plane is late in fixing them or changing their position, you might as well notice that very well. So one thing is variability, but it's also challenging because opposite or in contrast to variability, you want standardization, okay? If you have more and more type of devices on the other end, you would like to have less and less types or general types of devices when it comes to the operating system point of view. You cannot really treat each different mouse, each different keyboard as a separate thing. You want to have the concept of a keyboard, the concept of a mouse, so you want to keep it simple in order for the operating system also to be simple and modular and so on. And this is what I mentioned before. Each device has its own oddities. I can think about the wing flaps example. So to take care of input-output, this is what we said before, the operating system has part of it as a module that is in the kernel and it's about input-output, but it also relies on so-called drivers, so on external components that basically allow to do this translation from a generic keyboard to a specific keyboard that you're using or a generic disk to a specific disk you're using and so on and so forth. At this point, I hope that it becomes clearer why a specific brand of computers that only produces 3 types of computers and updates them only once a year and delivers both the hardware as well as the operating system as an easier job in claiming that their operating system is stable than another company that only does the operating system and wants that operating system to basically work on any laptop that is out there, okay, any type of hardware and so on and so forth. Hopefully now you should get a better understanding on what is happening behind.